Join me as I dive into the wild world of synthetic biology and see if I can design a fully functional human organ using AI. Synthetic biology is a field that combines engineering, biology, and artificial intelligence to create new biological systems, such as microorganisms, enzymes, and even entire organs. This revolutionary technology has the potential to transform the way we approach organ replacement, enabling us to create artificial organs that can mimic the function of real ones, potentially saving thousands of lives. Organ transplantation is a complex and challenging process, with many patients facing long waiting lists and uncertain outcomes. One of the main issues is the shortage of available organs, which leads to a significant number of patients dying while waiting for a transplant. This shortage is exacerbated by the fact that many potential donor organs are not suitable for transplantation due to various reasons, such as damage or disease. As a result, patients often have to wait for years, their condition deteriorating with each passing day, making them even more vulnerable to complications and reducing their chances of a successful transplant. The challenges faced by patients awaiting organ transplants are further complicated by the risk of rejection, which occurs when the immune system identifies the transplanted organ as foreign and attacks it. This requires patients to take immunosuppressive medications for the rest of their lives, which can have serious side effects and increase their risk of infection and cancer. Moreover, the process of finding a compatible donor is extremely difficult, and even when a match is found, there is no guarantee that the transplant will be successful. The combination of these factors makes organ transplantation a high-risk and high-reward procedure that is not always successful. In addition to the medical challenges, organ transplantation also raises ethical concerns, such as the distribution of available organs and the potential for exploitation of vulnerable populations. The high cost of organ transplantation and the limited access to healthcare in many parts of the world also create significant barriers to this life-saving treatment. These challenges highlight the need for alternative solutions, such as synthetic biology, which could potentially provide a more reliable, efficient, and equitable way to address the shortage of organs and improve patient outcomes. The development of artificial organs through synthetic biology is a rapidly advancing field, with significant breakthroughs in recent years. Scientists have made tremendous progress in creating functional artificial organs, such as hearts, lungs, and livers, using a combination of biomaterials, stem cells, and 3D printing. These artificial organs have the potential to revolutionize the field of organ transplantation, enabling the creation of customized organs that can be tailored to the specific needs of each patient. This technology could also enable the creation of organs that are resistant to disease and can be easily integrated into the body, reducing the risk of rejection and improving patient outcomes. Advances in synthetic biology have also enabled the development of new biomaterials and scaffolds that can be used to create artificial organs. These biomaterials can be designed to mimic the properties of natural tissues, providing a supportive environment for cells to grow and differentiate. Moreover, the use of 3D printing and bioprinting technologies has enabled the creation of complex organ structures, such as blood vessels and ducts, which are essential for the proper functioning of artificial organs. The combination of these technologies has the potential to create artificial organs that are indistinguishable from natural ones, enabling the creation of fully functional and implantable organs. The potential benefits of artificial organs created through synthetic biology are numerous, ranging from improved patient outcomes to reduced healthcare costs. Artificial organs could potentially be used to replace damaged or diseased organs, restoring normal function and improving the quality of life for patients. They could also be used to create personalized organs that are tailored to the specific needs of each patient, reducing the risk of rejection and improving the success rate of transplants. Additionally, the use of artificial organs could reduce the need for immunosuppressive medications, minimizing the risk of complications and side effects associated with these drugs. The creation of artificial organs through synthetic biology also raises new possibilities for the treatment of genetic disorders and diseases. For example, artificial organs could be designed to produce specific proteins or enzymes that are deficient in patients with genetic disorders, providing a new avenue for the treatment of these conditions. Moreover, artificial organs could be used to create personalized models of diseases, enabling scientists to study the progression of diseases and develop new treatments. The potential applications of artificial organs are vast, and the ongoing advancements in synthetic biology are bringing us closer to realizing the full potential of this technology. A compelling example of the impact of synthetic organs is the story of a patient who received an artificial trachea implant. The patient, a young woman, had been born with a rare genetic disorder that had caused her trachea to collapse, making it difficult for her to breathe. after undergoing an artificial trachea implant, created using synthetic biology and 3D printing, the patient was able to breathe normally and live a normal life. This case highlights the potential of synthetic biology to transform the lives of patients with rare and debilitating diseases, providing them with new hope and new possibilities. The creation of artificial organs through synthetic biology has also enabled the development of new treatments for a range of diseases and conditions. For example, scientists have created artificial lungs that can be used to treat patients with chronic obstructive pulmonary disease, a condition that affects millions of people worldwide. These artificial lungs can be used to supplement the function of natural lungs, providing patients with improved oxygenation and reduced symptoms. The potential of synthetic biology to create artificial organs that can be used to treat a range of diseases and conditions is vast, and the ongoing advancements in this field are bringing us closer to realizing the full potential of this technology. The transformation of a patient's life through the use of synthetic organs is a powerful testament to the potential of this technology. A patient who has undergone an artificial organ implant can experience a significant improvement in their quality of life, with reduced symptoms and improved function. The use of synthetic organs can also enable patients to return to their normal activities, providing them with a new sense of freedom and independence. The emotional and psychological impact of synthetic organs on patients and their families is also significant, providing them with new hope and a renewed sense of purpose. The use of synthetic organs can also have a significant impact on the healthcare system, enabling the creation of more efficient and effective treatments for a range of diseases and conditions. The use of artificial organs can reduce the need for lengthy hospital stays and expensive medications, minimizing the financial burden on patients in the healthcare system. The potential of synthetic biology to create artificial organs that can be used to treat a range of diseases and conditions is vast, and the ongoing advancements in this field are bringing us closer to realizing the full potential of this technology. For instance, the development of artificial kidneys could potentially reduce the need for dialysis, a costly and time-consuming procedure that is required for patients with end-stage renal disease. In summary, synthetic biology has the potential to revolutionize the field of organ transplantation, enabling the creation of artificial organs that can mimic the function of real ones. The current challenges of organ transplantation, including shortages and rejection issues, highlight the need for alternative solutions, such as synthetic biology. The advancements in synthetic biology, including the development of biomaterials, scaffolds, and 3D printing technologies, have enabled the creation of functional artificial organs that can be used to treat a range of diseases and conditions. Join the conversation and share your thoughts on synthetic organs in the comments below. What do you think about the potential of synthetic biology to transform the field of organ transplantation? Do you have any questions or concerns about the use of artificial organs? Let me know and I'll do my best to address them. Also, be sure to check out my next video, where I'll be exploring the latest advancements in gene editing and its potential applications in healthcare.